How's it going, guys? We got Peltier Cooler 2.0. A while back I made this, put this Peltier device into the back of a cooler, and it's been pretty good as long as it's plugged into a car. And, you know, of course, when you're driving down the road in a car, you keep the temperature inside the car at a reasonable temperature, you know, so this thing's sitting in a reasonable temperature. And of course, also a car has higher voltage than what a regulated power supply would be, so, you know, regulated power supply is going to be 12 volts, and that's what this device is made to run on. In a car, you know, you're going down the road, it could be 13.5 or 14 volts even, so you get a little bit more overdriving out of this device, which makes the cooler cool enough to put pop and stuff in while you're driving down the road. But plugging it into 12 volts just doesn't work, and then I'm looking at, I want to be able to take this to the garage and put it on the solar, and it's over 12 volts while it's running, but in the garage it's not 70 degrees, and this thing is just not going to be cool enough for me. So we got another Peltier device, and this one's a little bit bigger, and it came out of a little mini fridge. It's actually down here, and one of them went bad, and I've made a video replacing the one Peltier. There's two of these devices in it, and one of them went bad, and I looked up the part number on eBay, and I got a new device, exact same part number, and it wasn't as big. And these, excuse me, these things pretty much go by size. The bigger it is, the higher wattage is. You're not going to have one that's more powerful and then be smaller. And so somebody ripped me off on eBay. They sent me a part, you know, that had the right number, but it's probably 3/8 of an inch smaller all the way around. And, you know, so it's just, the refrigerator wasn't powerful enough. It would never shut off. And these things are inefficient. It's a bad way to refrigerate. I got a deep freezer. I put a kilowatt meter, which is right there. And that deep freezer cost me like $3 or $4 a month to run. This little refrigerator was going to cost me $10 a month to run. And it didn't even have, it had a smaller device in one of its coolers. It may have cycled on and off, maybe if it had the right size in there, but even at that, there's not much, you know, wouldn't have been a whole lot of difference between the, you know, what gain you'd have with the little bit bigger one in there. But anyways, these devices are good for certain things. Certain things, like you're going to be driving down the road, your car is only 20% efficient anyways. What's it going to matter if you're going to plug something like this into it going down the road? So, you know, it has good use for that. You know, you going for a road trip, you got a refrigeration, and I got that solar setup, and I'm putting a new solar setup in. I want to use the old one to run this, and it'll save me on ice and having water in my cooler and all that crap. So anyway, in this video we're going to build this thing, and I'll show you my power supply I'm going to have here for it. So here is the 12 volt power supply. This came out of the refrigerator, so it's probably capable of 8 to 10 amps, just guessing. I don't really see anything written on it anywhere. So, and it's regular, it's, you know, 12 volts, so I was looking at maybe making some kind of case for it. Pretty much what I want with this is that I can plug this thing in at the house and get the cooler down to temperature, and then so it has a head start. It'll only be used for like a half an hour or so, and then I can throw my pop in it, and then I can plug it into the car on the way to the garage, unplug it from the car, plug it into the solar, and so basically it's just a way to use this at the house to get the cooler head start on it. So what I actually decided to do is, I think I'm going to mount this to my cabinet here at the house, my desk for repair and whatever, And I'll have a regulated 12-volt power supply. There's a lot of things I work on that is car related, or maybe I might work on a car stereo or an amplifier for a car, and I'll have a 12-volt supply. You know, a station like this should probably have a regulated power supply that you can vary the amperage and the voltage on, but once again, most of the things that I'm going to work on is going to be, you know, stereo receivers, amplifiers, car related 12 volt type things. So this will probably work out good for me. So I'll have a way to pre-cool the cooler and also have a power supply here. I did fill this lid with insulation. A lot of these coolers do not have any insulation in them at all. It's just two pieces of plastic. And I took some of that foam, spray foam insulation, and drilled holes and filled this whole lid up. And it kind of warped it a little bit, but oh well. So it does have an insulated lid. I can tell you, before I insulated the lid, it was just like that device was doing nothing in that cooler. It wouldn't bring it down but maybe 10 degrees from room temperature before insulating the lid. And even at that, it doesn't have any seal around it. That has an effect too, because like when I put a towel over the whole thing, it had an easier time cooling the space with a towel over it. So, you know, it's not perfect. Alright, we got a gaping hole in the side of the cooler now. I just drilled 2 holes and then used a jigsaw to go around. And make sure that the hole is kind of snug so that you got a nice seal around here. You can see there's a gasket on here. And so it fits in there, kind of snug. You need to find some screws that either has a nut or something that goes on. In case I go all the way through, I can put a nut on, or find some screws that I kind of want to go all the way through so I can sandwich it. But I'll see what we get. Alright, got it mounted to the side here. I ended up using a drywall screw. I'm kind of limited on what I have here at the house with hardware. So right now they stick through the inside. I just got to figure out some way to put a protective top on those screw heads so that you don't get hit or scrape your hand across them. But one of the things is I got to put a fan on this side. So the fan's going to stick up like this. So whatever I put right here really isn't going to be in the way because that fan's going to be sticking up so far. Ran the wires in from the fan on the outside in, so I could tie all the wires together in the inside, and then I'll run a cord, you know, out. So it gives it a nice clean look from the outside. This fan's going to need some kind of guard, so that way stuff isn't running into the blades. Let's see what I got. Alright, that switch mode power supply ended up being a bust. Pretty much, it has several taps on it for fans, and if it knows if a fan isn't connected, best I can tell. And so it will not run unless you have a load on each one of its terminals, or maybe you might be able to put a resistor, you know, measure resistance of one of these fans and put some sort of resistor on it to make it think that there's a fan there. It's probably some kind of default thing so that if a fan fails, it shuts the whole refrigerator off. But I don't know, I can look more into it later possibly. But anyway, got a guard on this fan, and got this fan mounted in here. I'm not going to worry about that. It's so close to this that I just don't see anybody hurt themselves on it. But anyway, I mounted it this way so that I was able to use the plastic to hold it down. There was no other way to mount the thing down. And then I put a thermal disc in here that will shut it down before it freezes. It probably will never even cycle because I have my doubts that this thing can even get to the temperature of this disc. But it's in there just for safety's sake. Soldered all the connections and soldered all the grounds together. I taped up the grounds. I need to get some heat shrinking. oftentimes doing something, I need that heat shrinking stuff. Don't have any. But anyway, I'm going to finish up the inside of this with, I'm going to take the piece that cut off the outside, and I'm just going to mount it in here, probably just put one screw in it, and try to protect the wiring and stuff so it's not getting moved around all the time. Tied a knot in the wire here so it can't get ripped out, and there is a cigarette lighter end on it, and there is no fuse in this. This may end up being the top end of what a car fuse can do. So anyway, it's fused because you're going to plug it into a car or anything like that, it's going to have a fuse in it. So this right here wasn't even designed to have a fuse. So anyway, let's set it up. Alright guys, here's the finished product. Right there. Right now I have my voltmeter down in there because I was checking the temperature. I have no way of powering this thing in the house. Even if I was to bring a deep cycle battery in here, it would run the battery down so fast because these things draw a lot. I ended up changing the end that I had on it. You see here's the end that I had on it. This thing was just junk. It just would not stay in the receptacle. I hate the fact that they made this the standard for a 12-volt receptacle, but they're just terrible at staying attached. But there is better and worse ends. I took it for about a 40-minute drive, and it got to where that switch was turning on and off. That thermal switch I put in there. If I wouldn't have put that in there, this thing would freeze stuff for sure. It was cycling between 34 and 36 degrees Fahrenheit. 32 in Fahrenheit is freezing for those of you that is Celsius and not really familiar. So that's what that switch is, I think, supposed to be around 38 degrees Fahrenheit. It was the closest to freezing I could get, but given the fact that it's hooked to the side, it's touching the side of the machine, side of the case, it makes it so that it brings the degree a couple more down, a couple degrees lower, because it has, you know, it's touching a surface that's insulated, but you know, out to the outside of it. But anyway, this thing's pretty good. It's a lot better than the old one. I'll catch you guys later.